Okay, so for those of you taking organic chemistry right now, here's a quiz that can practice naming. If you're in Alberta, it's all old diploma questions. So the first question here is saying, what is an unsaturated hydrocarbon? If you are unsaturated, it means that you are not bonded to as many atoms as possible. So I'm just using 2 carbons as an example. To be saturated, it would mean all of these atoms that are not bonded would have hydrogens or any other atom on it. Now it's completely saturated. If you have a double bond, and we take this away, now you're unsaturated because you're not bonded to as many atoms as possible. So when we're looking at it and looking at a possible answer, this one would be B, because you have at least one double or triple bond. Just going through the other ones, saying a hydrocarbon which contains only a single bond, not going to be that. An alkane means only single bonds. And then the last one, a hydrocarbon which only contains one carbon atom per molecule. That doesn't really help us too much. So let's keep going from here. The next one, just being able to name it correctly, you need to identify your longest chain, which it would be 4 atoms. So 4 carbons in a row would be butane. And then if we numbered it from left to right or right to left, we get the same thing. So on carbon 2 and 3, you have a methyl group. So you would say 2, 3, dimethyl, because there's 2 of them, dimethylbutane. So the answer here was A. Keep going from here. Which of the following is 2-methylpropane 2-ol? So if we're going over this, just looking at choice A and B, we can rule these ones out, because right away, if we see that the OH group is on the end, it would not be on carbon 2. So looking at C, this looks like it could possibly be an answer, because we have the OH group on carbon 2, if I counted from right to left. But this longest chain would be butane. So it's not going to be a propane, because we need 3. So it looks like our best answer is going to be D. So let's just make sure. So if we pick our longest chain, and it wouldn't matter what way we went, we'd have 3 carbons in a row. On carbon 2, you have a methyl group and alcohol. So that's definitely going to be our answer. Now, the name of the following ester, we have the first part of our ester, which is going to be from the carboxylic acid, and then we have the part from the alcohol. So just looking over this, because we have the first, just this part from the alcohol was just 2, and if we're not sure, you could draw it out. So carbon double bonded to an oxygen, single bonded to another oxygen, and that oxygen would have that 2 carbon chain. This carbon here would have the rest of the chain. So when we're naming it, you would name the part that came from the alcohol first, and that would be an ethyl group. And then you would name the part from the carboxylic acid, which would be a propane group. So this would be ethyl propanoate. Number 5, study the following structure and determine the functional group present. So we definitely have a carboxylic group here, and we have an alcohol. So going through that and saying a hydroxyl and an ester, well, that's not an ester. This one is a hydroxyl. A hydroxyl and a carboxyl, that's going to be it. And just double checking the rest. We don't have any halogens, and the last one, we don't see a polymer. So we know our answer is going to be B. Number 6, the boiling points from smallest to largest in an aliphatic family. That just means that we're increasing, so it doesn't matter what we have here. So if I start with 1 carbon, then my next one would have 2 carbons, and then my next one would have 3 carbons, but we would have all the hydrogens around it. But as we get bigger, we're just adding a carbon each time, and the hydrogens that would go with it. So in terms of boiling point, as you get larger, your boiling point definitely increases. It's not going to decrease. It's not going to stay constant, because we'll have to put more energy in as we're getting larger. And this part as well is not going to, it's just, let's just say with increasing and stick with that. Looking at number 7 here, which of the following rows identify the condensed structural diagram or line diagram for an isomer of C6H12? So we want to just make sure that it's all lining up and that it is going to be true. So let's start going through. So that first one, we have 6 carbons. So 1 from the methyl group, and then we have 1 here, 2, 3, 4, 5. So 5 within our compound. Now we can 5 within the cyclic part, so the ring. In terms of hydrogens, we would have 2 at each of these points and only 1 at this top here, and then 3 at the very, very top from the methyl group. So if we counted those together, we'd have 2, 4, 6, 8, 9, 10, 11, and then 1 more here would be 12. So far this looks like it might be our answer because we want an isomer of C6H12. And so we now need to make sure that the name follows, and that would be cyclopentane. So this looks like our answer, but let's just double check the rest. So this looks like cyclohexene, we have that double bond. And then counting, so this, we definitely have 6 in our ring, and then each of these points would only have 1 carbon. I don't know why I said that. They would only have 1 hydrogen, and these ones would have 2. So 2, 4, 6, 8, 9, 10. So we don't have enough here, and then we can keep going, and I think we can tell that our answer will end up being A. Number 8, saying a mixture of liquid has methanol and a liquid ethanol can be separated. Anytime we are separating, it is kind of that idea with crude oil. If we want to separate it, we can separate by fractional distillation. And what allows us to separate anytime we're looking at fractional distillation is going to be boiling point. So we're good with that. So let's take a look at numerical response number 1. The structures and descriptions above that apply to methyl cyclopentane are numbered. So the first one, definitely not going to be number 1 because that has a benzene group. It could possibly be number 2, which it would be because we have that methyl group, whereas in number 3 we have an ethyl group. So we know our first one's going to be 2. When we're looking at this, because we have a group coming off of the chain, it is branched. So we can do number 4. If we didn't have anything coming off, we could say unbranched. We don't have any double or triple bonds, so it is saturated. And lastly, if you have no double or triple bonds, you are an alkane ending in ane. So that last one would be 8. Numerical response number 2. This is another common diploma question where you just need to be able to identify your molecules and then list it. So one saying an alkene, we're looking for an ending in ene, which we only have for number 1. An alcohol, we need to see that OH group. So that would be number 6. Which one are we looking at? YNE is what it ends in if it has a triple bond. And then cyclic means you need to see the word cyclo. And saturated means that we have all single bonds. So that can't be number 1 because it is cyclic, but it's not ending in ane. So then the other option is number 5, where we have cyclic and only single bonds. And then looking at question number 9, 2 properties that cyclopentanol and pentanoic acid have in common are that they have the same number of blank and that they are both blank. So because both of these have pent as their root name and they don't have any prefix on it, they do have the same number of carbons on their parent chain. So we're going to take out this alcohol part, and they do have different number of alcohols even if we drew this out. So we definitely are narrowing it between C and D. And then if you don't see a benzene ring, you are not aromatic. So it has to be aliphatic. So the answer was C. And I think that's the end of this quick little quiz. As always, I hope you found it helpful. If you did, please subscribe. And if there's any other video I can do for you, just let me know. Thank you for watching.